Man, this is honestly really not the headline I thought I'd be leading off the show with today. But apparently, if you had robots making love on your 2021 bingo card, you might have to put a question mark on it. Today on the show, we'll be looking at these insane tiny robots that can literally reproduce. And no, I'm not kidding. Okay, I seriously wasn't kidding. Scientists at the University of Vermont, Tufts, and Harvard have built what they call xenobots, tiny robots that can move around a petri dish, form Pac-Man shaped clusters, that's a direct quote, and apparently reproduce. Guys, Miss Pac-Man, Pac-Man, things are happening. Today I found a video from the University of Vermont that shows the process in real time, and a really nice article that explains the details a little further. For now though, let's kick it over to that video.
I can the degree very closely. Roger.
And ladies and gentlemen, I have video evidence. This is from the University of Vermont, their official YouTube channel, and this video is titled Xenobots Building the First Ever Self-Replicating Living Robots. Let's take a look. We thought we knew all the ways life can reproduce. Yeah, I thought so, but now scientists have discovered a new one. Oh boy. Say hello to Xenobots 3.0. That's cool. That's really cool. The world's first self-replicating living robots. In 2020, scientists at UVM and Tufts teamed up to hand-build computer-designed organisms from frog cells. Now they've built xenobots that can gather hundreds of single cells. Wow. Compress and assemble them into a baby and then release xenobot offsprings. What was that? Release xenobot offsprings from their Pac-Man shaped mouths. Okay, so this is not reproduction as we know it. This is some sort of reproduction. I mean, meaning that they make new organisms, correct? From clustering single cells. So it's not reproducing in the male/female sense, but instead from pushing these cells together. That's really cool. Living robots that look and move like themselves. Yeah, that's pretty cool. We found xenobots that walk. We found xenobots that swim. And now in this study, we found xenobots that ... replicate. What else is out there? That's Josh Bongard, UVM robotics professor. Really, they can swim, huh? And walk, like bipedally walk? Interesting. Wow, honestly, okay, that was a pretty crazy visual. Just seeing that little thing zoom around like that. I have another article for us to look at that I think will shed a little bit of light. I still have a lot of questions about the xenobot. Guys, let's go ahead and jump over to that.
I can the degree very closely. Roger.
And our article today comes from newscientist.com and was written by Carissa Wong. Thank you, Carissa. Really appreciate it. Living robots made from frog cells can replicate themselves in a dish. Swarms of tiny quote-unquote xenobots can self-replicate in the lab by pushing loose cells together. The first time this form of reproduction has been seen in a multicellular organisms. This is pretty crazy. Xenobots, interesting. I see that they're referencing a frog species here. Let's go ahead and read a little bit more. Swarms of tiny living robots can self-replicate in a dish by pushing loose cells together. The xenobots made from frog cells are the first multicellular organisms found to reproduce in this way. Found or created is probably the question, because I saw a computer graphic before kind of explaining the machine learning AI. Xenobots were first created last year using cells taken from the embryo of frog species Xenopus laevius under the right lab conditions. The cells form small structures that could self-assemble, move in groups, and sense their environment. Okay, that is pretty incredible. Some important notes here. Under the right lab conditions is specifically specified. And yeah, again, this is made from organic frog cells, so this is artificial in a sense, but there's an organic component, which is really freaking interesting. Now, the researchers behind the work have found that xenobots can also self-replicate. Josh Bongard at the University of Vermont and Michael Levin at Tufts University in Massachusetts and their colleagues began by extracting rapidly dividing stem cells that are destined to become skin cells from frog embryos. When the cells are brought together in clumps, they form spears of around 3,000 cells within 5 days. Each clump is around 0.5 millimeter wide and covered in minuscule hair-like structures. Fucking bizarre, man. These act like flexible oars, propelling the xenobots forward in corkscrew paths, says Bongard. Wow. That is honestly incredible. I'm kind of just stunned by all of this right now. The team noticed that individual clumps of cells appeared to work together in a swarm, pushing other loose cells in the dish together. The resulting piles of cells gradually formed new xenobots. Further experiments revealed that the groups of 12 xenobots placed in a dish of around 60,000 single cells appeared to work together to form each one of or two new generations. Wow, okay, again, some more interesting thoughts here. Either one or two generations doesn't seem to happen indefinitely for some reason. And again, this really seems to have something to do with these exact stem cells that apparently were destined, to become skin cells in frogs. There's some unique properties associated with it. It's very interesting. One xenobot parent can begin a pile, and then by chance, a second parent can push more cells into that pile, and so on, generating the child. Okay, so again, it's not trying to say that there's some crazy conscious thing happening here where they're collaborating. It's more so they're in a petri dish, and they're all doing these kind of rapid movements to gather up more cells, and one's rapid movements is going to affect the other's rapid movements and probably help it. In a sense, guys, this is incredibly interesting. So again, a little bit of notes here. This is a robot technically reproducing, but not from the reproduction as we know and love. This is a different kind of cluster forming. Is that what they call it? I think it was something along those lines, where they're going around and moving around and collecting little cells until they become a clump. And essentially, if you do that enough, I mean, that's reproduction, right? The other two caveats here, they're just important to note, and you can't really get across in the headline. This can only happen in a lab setting, right? And this is specifically happening with these exact cells that are organically from certain species of frogs, right? So we can't exactly sit here and say this is entirely a robotic being that is now reproducing. There's organic layers involved. But nevertheless, this is bananas. I cannot even begin to imagine where this goes from here. I don't know if anybody can. I would love to know your guys' thoughts. Thanks again for watching. I know this video is only the second one on this channel. Hey, thanks for being here, however the hell you found it. And think about subscribing, because I'm doing this after 11 p.m. at night. Just making videos. Think about that. Guys, have a good day.
Ag, staying to the green very closely. Roger.